Welcome to MacroHive Conversations with Bilal Hafiz. MacroHive helps educate investors and provide investment insights for all markets from crypto to equities to bonds. For our latest views, visit macrohive.com. Greetings, Chris. It's great to have you on the podcast show.
Thank you very much.
Now, before we go into the heart of our conversation, I do like to ask all of my guests something about their origin story. What did you study at university? Was it inevitable you'd end up in academia focusing on economics and AI? Tell us a bit about some of the key milestones that you've had until now.
So it definitely wasn't a pre-programmed path, I would say. So I studied my undergraduate degree in Aachen in Germany and in Perth in Australia, a dual degree, which was international business and economics. So a bit more the on the business side. And after that, I was more interested in the economics part and the quantitative part. So I decided to do another master's on top of that. And but I enjoyed this multiple country thing. So I did a master's program called Erasmus Mundus, where I spent one semester in Bielefeld in Germany, then one semester in Paris, and then the second year in Barcelona.
Right, that's the Erasmus program, isn't it? The famous European Erasmus program. I'm not sure if the UK can still participate in that now that we've had Brexit.
I think they decided they didn't want to.
Okay. Yeah.
And yeah, so it's and this is a bit different than the typical Erasmus. Typically, Erasmus is you're studying somewhere and then you go study a semester abroad. Whereas here, a group of universities come together and invent a sort of specialized program. And then I think the basic idea was to compete with US universities and attract also a lot of Indian, Chinese students who would typically go to the US. And so it was a great mix of people from all kind of different countries, and we bounced around these different countries. And I enjoyed economics, but I had no idea about academia. So then at the end of this coursework of the master's, I actually went into a small consultancy in Barcelona called Neometrics. And that was kind of, I'd say the work they were doing was ahead of its time. So we were doing a lot of personalized recommendation systems based on big data. My main project was an automated newspaper allocation across 3,000 points of sale. So lots of machine learning. And we're speaking 2009 to 2011, when this wasn't everywhere yet. And I really enjoyed that work. And anyway, decided that I wanted to continue economics and do my PhD and continue in Barcelona. But that always had an influence on me, this experience, these 2 years of the pragmatism of the private sector, of having to make useful things and use data, so let the data speak in a way. So when I went back to economics in the beginning, it was a bit of surprise again, how theoretical it was back then, and which I think has changed a lot. So yeah, so then I finished my PhD in Barcelona, and those were the end of my studies. And there I then played the lottery of the job market that we economists do, and ended up in a postdoc in Cambridge.
Okay, and that's where you are now, and you've been there for a number of years now.
Yeah, so then I was a postdoc here, then was an assistant professor in Montreal for 2.5 years at the University of Montreal, and then was contacted here by Cambridge again to come back, and so that's why I'm here again.
Right, no, that's great story. So I mean, you're actually quite well traveled, it sounds like, through your various postings over the years. So you do like to be a very sort of global academic, so to speak.
Yes, I enjoyed all of the different stints in very different places, different systems. People think differently about problems, and I always was in like very international groups, so not everywhere did I have too much exposure to locals, actually. That also differed a lot from place to place, but I really feel like I so I definitely enjoyed each of those different places, but I also learned different things in each of the different places.
And I just had a kind of a tangential question, well, related question to universities. And obviously, Cambridge is world renowned, has an excellent reputation. You know, Oxford, Ivy League, Harvard, Princeton, all of these places, you know, have great reputations. I mean, what do you think makes somewhere like Cambridge so good academically? What is it? I mean, is it like a legacy issue just because of its history, or is there something current about it that makes it so special?
Um, it's a lot of things. So it's supply and of very good students. That's one thing. Very good students want to come here. So I see that. We interview every undergraduate we admit to college, and it's really hard to choose. They're incredibly good. So it's different than in other places where it's a bit more of a mass model of, okay, let's accept 500 students, whoever applies, basically, which is often driven by government incentives of driving up numbers for tuition. So very good students want to come here. Why do very good students want to come here? Well, one reason is also the brand name, the legacy. People like to have University of Cambridge on the diploma they receive in the end. But also here, there's this unique-ish Oxbridge system of supervisions, or in Oxford, I think they call it tutorials. We have the small group teaching of like 2-3 students with professors. And since you went to Cambridge
I
as
have
well,
really quite mixed memories about that. Very painful, nowhere to hide when you're like with your one fellow student and you have a professor or associate professor grilling you on concepts.
you can't hide, but it goes
You can't
both
hide.
ways. So it's also for if you're on the other side, if you're the one giving the supervision, you also can't hide.
That's
Because
true.
it's very interactive. You get questioned about the material, where often in like large group teaching, it's a bit more monotone. Um, um, so I think that's something that adds a lot to students, and then also network effects. Of course, if you have good students in a good program, they're going to do well later. They might be coming from Some of them are coming from very well-connected backgrounds as well. So of course that can also catapult you into different positions in the future. So not just from like that unfair lobbying perspective, but also in terms of peer effects of rubbing off, of thinking big. Not everyone thinks about doing a startup or the ability of landing some great job. So I think these things all together um, create the outcomes that we see amongst the student body here.
No, that's great. Now, one of the reasons I wanted to get you on as a podcast guest is your work that you've been doing on predicting conflicts, which you've been focusing on, I guess, for the last few years. Some of your papers have been released recently, but I imagine it's off the back of a number of years of work, just the way academia works. There's a paper you published. I think it got published in December of 22, which was the hard problem of prediction for conflict prevention. But the essence of the paper really is about predicting conflicts in regions which don't have a history of conflict. So perhaps you can kind of give an overall outline of this body of work, and then we can go into the details.
Yeah, so this was inspired by what I was mentioning before, the predicting newspaper sales and so on. So that's where my affinity to prediction came from when I started my PhD, because that's when I started these projects with Hannes Müller in Barcelona. And in the beginning, the reception was mixed in economics. People did not really think that prediction is something we should be doing. It should be more about causal inference, theoretical models of what is driving conflict, and so on. I think all of those things are important, but I think it's also important to know where things might be problematic. And we know that there's also from our prediction work that many things that have been identified as causal in certain regions or situations do not really extrapolate to the world and are not great predictors of where conflict's going to happen. And if you have, as a government, citizens abroad, or as a company, you have investments somewhere, or If you yourself are thinking of traveling somewhere or moving you might want to know where there might be problems. Also help different agencies might want to think about where to prepare for refugee camps and things like that. So I think there's a lot of practical need for it. So that's why we, despite the mixed reception in the beginning, continue to drive this agenda. And
actually, just as a side point, if it's not an economics department, which other department would try to tackle an issue like this?
So
where would this fall?
political economy at the point when we started this, as not political, politics, the political science, they were much more open to prediction when we started this project. And that's why we also have our first project, Reading Between the Lines, using newspaper text to predict conflict, is published in a political science journal. And lots of economists would say when we present this, they would say, this is really nice stuff, but you're not going to be able to publish this in economics. So in the meantime, that has changed a bit. There's more openness also to using machine learning, which was a bit new back then. And that's what was pushing us, that there were all these new methodologies of looking at newspaper text, summarizing it using machine learning. And I think we also discovered some things that were important for theory. So I think theory and also other prediction models that were out there at that point were very good at predicting where conflict might happen. So for instance, that the Democratic Republic of Congo is at higher risk of, say, the Netherlands, due to different factors, that structural ones and so on. But we didn't know much about the timing. So when conflict might break out. And that's something that we really have been focusing on. And when we have been focusing on that, that's also how we started thinking much more about this hard problem. What we call the hard problem is conflict in places where there's been no conflict before. Because since conflict is so incredibly damaging and also recurrent, you have the best predictor of conflict is past conflict. Okay, so that...
Just as an anecdote, back in the 90s, after I left Cambridge and I joined JP Morgan, my first job was to use kind of econometric models, the latest stuff back then, to predict emerging market crises. And I built all these really complex models, and in the end, I found what outperformed all of those models was a neighboring country experiencing a crisis or not. So you end up in this situation where it's these kind of very simple things that end up predicting a crisis rather than the more complex things. So you're right. It's important to distinguish between predicting conflicts generally versus conflict, the hard problem of conflict.
No, and I mean also along the similar lines as what you just mentioned. When I started with the newspaper project, it was very hard to just beat last week's sales or an average of last week and last year's. So often simple models are very hard to beat. So machine learning is not automatically magic. It's you have to use it carefully, and especially how you evaluate it is very important. And in this evaluation is where we were then really digging into this hard problem of the countries that were previously peaceful. And not only from a predictive perspective did we think that's important, but also from an economic perspective. And we're working much more into that direction now. Is since conflict is very recurrent, extremely damaging, the conflict you'd really want to avoid is the first one. Because once there is a conflict, you have all the open wounds. You have factions in the society. You have economic growth that has been set back for years due to physical damage, due to the cut ties in trade and infrastructure that is destroyed. So you really want to avoid that first outbreak. Now, the problem is those are extremely hard to predict. So you can get a very good predictor by saying there's always going to be conflict in one set of countries and there's never going to be conflict in the other set of countries. that on average, that predictor is going to work very well. But of course, from a policy perspective, that's not very informative because you're never going to avoid this first conflict anywhere. Assuming we know what to do, that's another problem. So let's assume we know how we can reduce conflict risk. Then you really want to know, where is conflict going to happen where it's never happened before. Okay, so we still on average perform poorly in those places, so we're honest about that. Yeah. But since the baseline risk there is so extremely low, even if we just predict the probability of 4% and that there's going to be conflict in a place where there hasn't been one for 10 years, that doesn't sound great. Yeah. But the baseline risk is something like 0.1%. So we've increased that 40-fold. Yeah. So then you can really talk about economic gains of these models, that if you were to allocate resources to avoid this conflict, you might actually really save lots of money down the road. And the other problem, so besides that policymakers might not know what to do to avoid that conflict, the other problem is if now you act and you avoid a conflict, then it will look like you didn't avoid anything. So the whole political economy is very complex here as well. If you avoid a conflict, it will look like there never was a problem. So the question would be, why did we go there? Why did we spend all these resources? There was no problem. So that's why the policy world often tends to focus on where it is burning, where there currently is conflict, because obviously that seems much more urgent. And it looks much more effective if afterward it's not burning anymore. But the problem is, even once you've put that fire out, you just have a very high probability of a
So there's an issue of like counterfactuals, I guess.
Yeah.
You kind of need to have a counterfactual mindset to understand that what could have been. I actually had about a year ago, I had Neil Ferguson, the historian economic historian on, and he's a big proponent for historians to look at counterfactuals as a way to really understand history. It's quite a compelling argument, but obviously the default for people is not to think in those terms. And so you're right. It's, if you prevent a crisis or conflict, then people will say it wasn't going to happen anyway.
Yeah, I think economists are bad at many things. One thing I think they're decent at is thinking about the counterfactuals.
Yeah, opportunity cost. I mean, it's ingrained in economics, so that's good. So let's kind of dive a bit deeper into this all. So you've set yourself the task of trying to predict conflict in regions which haven't historically had conflict, which is the so-called hard problem. Now, first up, how do you define a conflict?
Yeah, there's whole conflicts about that. we in a way, we stay out of that. We take this incredibly good data by the UCDP, which defines the number of battle deaths in different places at different points in time. Of course, there's people who question these numbers. There's alternative data sets. I think all these discussions are super important, and there's other databases that are growing and are very good as well, such as ACLED and so on. We don't enter that battle. We focus more on, okay, let's assume these are the correct numbers, and we are going to try to predict them. And that has a few advantages. So one is basically our models are very robust, that if you change whatever you're training them on, they're going to adapt to the patterns in that quite nicely. So if one day someone comes along and says, look, here's this much better database, then we don't have to change much. We train the model on it, and we get very good output as well. Problem always is these things have to date back quite long in time, because machine learning models are data hungry. Luckily, there are not many conflicts. So the model doesn't have so much variation to learn from. So you need long timelines. And
just to be clear on the battle deaths, that doesn't just mean a kind of a war between two nation states where there's a battle.
No, so typically what we focus on is what also exists much more are civil conflicts.
Okay.
And here there are also debates on what should enter there and what doesn't. I forget the exact definition, but it's something like there's an actor who attacks the government, and it's politically motivated. So, for instance, terrorist attacks tend to be coded as conflict in these
So
data.
something like 9/11 in the US, would that be classified as a conflict or not?
Yes, I think that would. Yes.
Okay. Okay. Yeah.
So that would show up as battle deaths in this data set. And also a lot of the conflict deaths in Ukraine show up as this because it is a mix of a external war, but there's also the internal war of the regions that are within Ukraine that might want to break out. So there's all kind of issues surrounding this data. It's a very hard task for the people who are creating these great databases. And then it's still a question of how do we define conflict. So there's different ways of going about that. There's a lot about threshold models. So one says more than 25 battle deaths, more than 100, or at least one. We like to use that one often because that's quite clean. Like there's 0 battle deaths or there's some. Yeah, there's 1 or 1,000. So then you talk about probability, and then we also use models where we look at this per capita. So obviously it would be different to have 10 battle deaths in Luxembourg versus China, just because they're very different population numbers. So we use the per capita as well. And also we do have models that predict the actual number of battle deaths, so the intensity of conflict. So here, there's a lot of debate, and each of these approaches has problems and each of them has advantages. So basically, again, we have models that are robust in a way that depending on what you train them on, they're going to work quite well.
Okay, no, great. Okay, so okay, that's what we're trying to predict. And then in terms of the features or the variables that you're trying to use to help you predict the prices, some people have talked about commodity prices, for example, when food prices shoot up, higher likelihood of crises. There could be, recessions or something like that. How did you go about thinking about the features you'd look at to help you predict these?
Yeah, so there's a lot of theoretical literature in economics that I was talking about before, and also the literature looking at the causal drivers. And in certain contexts, they seem to be influencing conflict. That's what these well-executed studies find. But we found that a lot of these variables, when you're predicting at a global level, do not add much predictive power once you include information about past violence. So a huge chunk of predictive power you can just get by using certain patterns of past conflict. So when it last appeared, how harsh, and so on. So that already builds a great model that is extremely hard to beat. And now the problem is obviously that's never going to predict the hard cases. So there, we've really leveraged newspaper text. So newspaper text is great because it captures all these structural features of what's going on in the economy, what's going on in society, and it does this across the entire globe, and you get long historic data, plus it's updated in real time. You can get that data today. So a lot of models use variables that are published months later. So you're basically predicting into the dark. They say if you use GDP or something like that, those are often not published until 6 months later or so. So any current movements will not be in there. So that's why at some point we found that basically none of these variables add any additional information once we use past violence plus the newspaper text. Now, of course, the newspaper text has a problem of the dimensionality. The newspaper articles are long. There's thousands of words. We have 6 million of them. So there is where machine learning really comes into play and reduces this dimensionality. And there we use what are called topics. And these topics, they can be understood as urns where journalists draw from when writing about certain topics. And you can imagine a journalist writing about sports is going to draw words like team, win, and goal. And when writing about conflict, they will draw things like army, war, and bomb. And these are the words that then generate articles. Yeah? So we know what is being written in each country or in each location at each point in time. And this information adds a lot, especially when predicting hard cases.
So what you're saying here is, okay, you use news stories, but there's a dimensionality problem, right? There's way too many news stories for you to kind of model. So then you deal with the dimensionality problem by using topic modeling. You kind of collapse things into topics.
Yeah.
In your paper, you talk about LDA, which is an approach used in machine learning. Now, do you dynamically sort of pick like model the topic so that every year, like it's like a moving window of, okay, these are the 20, 30 topics, or is it static?
It's a mix out of computational reasons. So what we do is every year we re-estimate all the topics with the entire data that exists. And then each month of that year, when we update, because we're updating our website every month, we just update using the existing topics with the new information that comes in that month. So this in normal times works very well, and also in some testing periods it worked quite well. So for instance, when COVID popped up, this didn't really exist in any of the past topics, but then we saw that those words related to COVID were starting to really populate what seemed to be like the health topic. But of course, you can imagine that if you never update them and you'd only have topics, say, that were given by the year 2000, and when society changes a lot, then you might be trying to squeeze words into topics that don't fit anymore. So that's why we do this re-estimation every year. But since that takes a lot more time, we don't want to do it monthly. So on a monthly basis, we just do this dynamic updating.
And within the paper, you describe some example of the topics. So I'm just looking at, table B1, and you have so overarching topics like justice, Middle East, economics, current events, industry. And within those, so for example, under justice, it will be court, case, investigation, I guess, arrest, office, prison, charge, justice, and so on. So that's kind of the approach that you take, which is a fairly, within the topic modeling arena, this is kind of a fairly orthodox way of doing this.
Yeah, I mean, but what people first were doing when they started using text was using keywords. So people thought about, okay, what's related to conflict? Things like war, violence, army, weapons, and they started counting these words, and that worked quite all right. But what, of course, you're missing is whatever you maybe didn't have a preconception about. So you don't have the negative associations with conflict either. So that's why what we like about the topic model is that then we found that, for instance, the law and justice topic is a strong negative predictor of violence. So when that topic share goes down, conflict risk goes up. Or similar about tourism. Yeah, when less is being written about tourism, we see that conflict risk tends to increase. And that's what's nice about these topics. Now, what's an issue about the number of topics is you can take it to the extreme and do 1,000 topics, and then you'll get topics that are very specific to some situations. You'll have a topic that is the Balkan Wars. And of course, if you're trying to predict, then the Balkan Wars are not going to do well at predicting a conflict in sub-Saharan Africa. So then you want to have more generalization. So you reduce the number of topics, but then if you reduce it too much, then you might get topics that are just too general. So there's a trade-off there. And so we choose like an intermediate number of 15, 20 topics. It's the results don't hinge exactly on that number, but we found that moving in that range works well.
So now kind of we have the features, which is the topics that you derive from this big data set. You have the sort of the prediction side. Now, from a modeling perspective, there's a number of different approaches you could take. One is the econometric approach, using logic models, those sorts of things, or there's a machine learning approach. And then within machine learning, you could use SVM, support vector machines. You could use decision trees, gradient boost, random forest, neural nets, and so on. So can you give me some of your thinking around why you picked a random forest, which is what you ended up going with?
Yeah. So linear models work very well, actually, because in this case, we don't have that many features. We have like the 15 topics and a bunch, 5 to 10 variables capturing past conflict. So it's not like that we're throwing hundreds of thousands of variables at the algorithm and asking it to find out which ones are good at predicting conflict. And in this case, that actually wouldn't work very well because there are just not so many conflicts. So if we would throw 1,000 variables at it, then it would probably completely, using, say, lasso, then it would completely overfit to certain situations, and that would not generalize to others. So that's why by imposing our own priors, this own structure of okay, these are good predictors, it already changes the set of predictive algorithms you might want to be using. And here we basically found that random forests are extremely robust. So other people, the team around Harvard Hagra and others, they've also found this. It's a bit surprising maybe because it actually doesn't exploit the panel dimension. It's not a time series model either, but it's just very strong in avoiding overfitting. You don't have to get the parameter tuning perfect. It just works very well, and it's very robust in capturing the relationships. As I said, a linear model already works very well. If we just run an OLS regression, that would work very well in our case because we don't have so many variables. But we do find that there's improvement using the random forest just because of how robust it is. Now, why random forest and not others? One reason might be because we're just not well enough trained in computer science to leverage the power of other algorithms. Other is we might not have the computers that are fast enough to get the hyperparameter tuning right. So going forward, I think we will be moving much more in the direction of neural networks, which is obviously an exploding area. We have used them in the past. They did work quite well, but there's a lot more moving parts there. And so it's not quite as robust and much more subject to what the user is doing and deciding. So that's why in the past, I think it hasn't been so prominent in our work. But I think in the future, that's what we're one of the things we're working on now, and that's something that we're definitely going to try to exploit more.
And I guess in some ways, if OLS and linear models still work well, that's also quite reassuring in some ways, because then it kind of tells you, okay, you're not just like using some really like non-linear complex algorithm to squeeze something out. So it kind of tells you there is something here, and now you're just trying to refine it.
Indeed. So it's comforting in a way. We don't rely on some black box that gives us super counterintuitive results and magically turns into a great prediction. Random forest really adds only at the margin compared to say a OLS model. It clearly does, but really at the margin only. So, and as you say, I also find that comforting that because obviously the fear with machine learning is always the black box, one of the fears, and I think that's at this point something we don't have to be so scared about.
Yeah. Okay, let's talk about the results of the model then. So, the way you kind of looked at the results was that you looked at how the model predicted all conflicts, and then how it predicted conflicts if you exclude conflicts which have a history, which is the hard problem. So maybe you can sort of run through the results.
Yeah, so that's where we really try to be honest. I have two reasons. One, because as I stressed before, because I think it's important. But the other reason is also because in relative terms, we do well there. So in absolute terms, as I said before, we do terrible. So these are really hard to predict. But compared to the baseline risk, so what like a random predictor would generate there or so, we have high predictive power. So of course, the longer you move away from the last conflict, predictive power tends to go down. But that's also because you have less and less training data, and also less and less cases in general to evaluate. So at some point, you might be talking about 10, 15 cases that you're evaluating this on, and then how much trust can we put into that? But so if anyone is concerned about the academic papers that we might be overfitting there or cherry picking, so we publish every month on our website our predictions. We lean out the window and put them up there in I would like to say real time. Of course, there's a bit of a delay with data being published and so on. And we do evaluate those predictions from time to time. And we find that we do very well there as well. So that's very important to us to not be overfitting.
Yeah. So just to add on that, we'll include this in our show notes. But I think the website address is like conflictforecast.org.
Yes.
And there you have a nice sort of world map that kind of dynamically changes, and then you have a tab somewhere which you can look at the history as well. So you're extremely surprisingly transparent, I have to say. You're really putting yourself out there, which is fantastic. So it's a really nice kind of way you've done everything. Present the work with the paper, then actually show the out of sample live results, so to speak. So that's kudos to you for doing that.
Thank you. But I mean, the reason is we want this stuff to be used as well.
Yep.
So we talk to a lot of international organizations, NGOs. We work with FCDO here in the UK, with the German Foreign Office. They're interested in our predictions. They want to understand them more. We want to understand what they want to know, how they use these things. There's great exchange going on at the moment. So what we really are trying to understand is, what do they do with these predictions? So imagine they would trust our predictions. What would they actually do with them? And this is then what I mentioned before, where I said, assuming we know what we can do to avoid conflict. So that's something we're really working on more now, is when we're talking with policymakers, is we're trying to understand what they did in the past, so that we can study how policies might be affecting conflict risk. Because a bit of a dark black spot in all of our prediction models is they're assuming that nobody is implementing any policy there. But if obviously in the background there's a lot of diplomacy and whatever going on, and that might be biasing our predictions. So the predictions still work quite well, but we want to know what policies do to conflict risk out of two reasons. One is because we want to reduce conflict risk, but we also want to improve our predictions. We want to clean this bias out of our predictions, and that's why we're really trying to work closely with these different actors.
Oh, that's interesting. Yeah, because I did find in your paper, when you added things like oil prices, food prices, it didn't really improve the predictive power of the model. But instead, if you were in the future work out XYZ policies make a difference, that could actually become a feature that could actually improve the model. So this next phase of your research could actually end up on both ends. One as a policy prescription, and then the other side, predictive model improves as well.
Yeah, and the other way we're using the predictions is we did a study on power sharing agreements, and they tend to have a bit of a bad rep, because if you look at them at face value, they're often followed by violence. But obviously, they're being put into place when there's super high risk. Otherwise, you wouldn't bring people to the table and say, let's do a power sharing agreement. So then we can use our predicted risk to compare two places that were at equal risk. One of them had a power sharing agreement, the other one didn't. And then you actually see that power sharing agreements are often followed by violence. But again, talking about the counterfactual, they're followed by much less violence than my equally high risk place that did not have a power sharing agreement. So we're also trying to use our predictions in that way.
Yeah. And also just another point. I think you also, again, you do this. You have covered this in your research. There are other bodies, think tanks, and so on that kind of have measures of risk around the world, and uh, you know, different companies sort of provide these risk metrics. How did you find those in comparison to your models?
So most of them tend to just track violence.
Okay.
So they're typically telling you conflict is going to happen where it either is happening already or where it just happened. And that is true. That is not wrong, but obviously you're with those type of models, you're going to miss all the hard cases. And often that's also reflected in the variables that these type of models use. They tend to use often very slow moving variables such as GDP per capita or infant mortality, these kind of indicators of or demographic features of like the share of young men in a society, which tends to correlate with outbreaks of violence or so. And as I said, on average, these models do well, but they're a bit more maybe of a conflict tracker than actually a predictor of sudden outbreaks.
Yeah. Now, in terms of results of the model recently, I mean, have there been any conflicts that your model kind of predicted that did actually happen over the past few years?
Yeah, I tend to try to avoid those type of one shot
Yeah, it's kind of cherry
examples.
picking and it's biased and yeah, no,
But
that's
of
fine.
course, one is often evaluated in that way, and I would call it luck in our predictive exercise. But my co-author in all of these projects, Hannes Müller, he published a post on LinkedIn about how the risk model within Russia was shooting up, and then 3 days later, the Wagner rebellion happened. So this also caught some traction internationally that we predicted the Wagner rebellion supposedly. Um, I I think it was a mix of coincidence, but yes, there was also obviously with all what is going on in Ukraine, there was reason for changes in risk. So it wasn't completely random, maybe that our model worked well there. But I'm sure if
No, I
we,
understand. I mean, you said
yeah,
earlier, various points, the absolute predictability is fairly low, but on a relative basis versus what we have out there, this is much better. So,
but I mean, there are some surprising predictions that are hopefully not going to materialize, probably not going to materialize, but just you see an uptick in risk in the model, and then we tend to flag that in posts on say Twitter or LinkedIn, and they're currently Sweden or Belgium have been featured and received some attention because I mean, in Sweden, there's been a lot of a surge I mean, a relative surge in violence, and of course, we would never imagine civil war in Sweden, but just in relative terms, the probability has gone up drastically. In absolute terms, it's still extremely low, but in relative terms, it's at much higher risk than say maybe it was 10 years ago. And we just think those are things we have to focus on. Just you don't want anything to ever spiral out of control just because historically it seemed like a safe place.
no, that's great. Okay, now, that's fantastic, and I'll attach a link to the live website, then also to the research paper as well. I just wanted to touch on one other area of research that you have done, which is on parenting styles, and in relation to how parents raise their children or how it impacts their children. Many people, myself included, and listeners are parents. Can you just kind of very high level talk about some of the sort of the general work you've been doing on that side?
Yeah, so I have some other work on human capital in general. I've always been interested and concerned about inequality, intergenerational mobility, and the social fabric in some sense. And in this paper that you mentioned, in a way, these two ideas come together of using machine learning and thinking about human capital. So we actually used the latent Dirichlet allocation, the LDA topic model, to try to detect parenting styles, because as you mentioned, parenting is very complex. I also have two kids, and I know that. But most of the work there is using summary measures that is based on work by psychologists from the 60s, who looked at a few parents interacting with the children, and then clustered these styles in like a theoretical way. Now we thought, okay, nowadays we have more and more data. Maybe we can detect these kind of clusters, or what clusters will appear if we just let the data speak. Maybe parenting styles are actually very different than the way we think about them, and those that tend to be successful also are very different. So this was actually inspired by the work by Stephen Hansen and others who already did this with managers. So they looked at managers' time use surveys and how managers use their time, and they find two different types of managers, the micromanager and the big picture one. The big picture one tends to do better. And I thought maybe we can do this for parents as well. So it's a bit more of a proof of concept paper. The data was not optimal, not that many observations, not that many different interactions. At the same time, very good data. And what comes out of it is something that lines up quite nicely with what psychologists came up with in the 60s. So if we ask it to come up with two parenting styles that it detects, basically has the warm, interactive parent, the one that cuddles their child, responds to it, doesn't yell at it, gives it toys. Yeah. And this is coming from the observation of people interviewing the parents. So it's not self-reported, which is nice to avoid those bias. And then the other type of parent is more just a cold, maybe even neglecting. So those are the extremes. People are a mix of these types, and there's a continuum between them. But the extremes then are, the other one is the cold, who doesn't really do anything, doesn't yell at their child much either, doesn't really give them toys. If they do something, they basically just check on them and see. And then we can look at how this changes with the age of the child and how parental backgrounds predict these styles. So we find more educated parents tend to be more of the warm style. And we can look at how it correlates with child development. So children exposed to the warmer style, they're more develop better cognitive and non-cognitive skills. So there's not a lot of causal evidence in this. It's not a randomized control trial or something like that. But as I said, it's more of a proof of concept that I think we should be using much more pattern detection that machine learning allows in these different research questions as well.
Yeah, that's great. It's good to know. I'll include a link to some of those papers as well. Now, I did want to round off with a couple of personal questions I'd like to ask my guests. One is, what advice would you give to students leaving university as they enter the real wide world?
That's a hard question. So here I would say a mix of listen to yourself, but also listen to others. So I think way too often one tells people like everything is possible, follow your dreams and so on, which I think can lead people down terrible rabbit holes. There isn't not a lot of knowledge out there. Don't throw the baby out with the bathwater. But at the same time, there's also the other extreme of you have to get this well-paid job, start your career, and do this, and not one size fits all. So I think a lot of it is about sampling. Yeah. So if one is not sure of doing that additional master, well, maybe don't do it and work for some time. And then if you want to do it, go back to it. That's what I often tell my students here who are just finishing their undergrad and they think, oh, I'll do a master's because that's kind of what one does. I often tell them, look, why don't you take up that job offer that you have, which also sounds interesting to you? And then after 1 or 2 years, if you want to go do the master's, you'll have, number one, some money saved up, and number two, you'll know much more about what you want later on, potentially. So that's why not one size fits all. Sample different ideas, maybe. Yeah. Don't think of locking yourself into something forever necessarily. But maybe I'm also a bit of an extreme of bouncing around different things. So yeah, then there
Okay,
maybe
that's great.
listen to yourself more.
Noted, thanks. And then the final question I wanted to ask was on books. What are some of the books that really influenced you over your career?
So neither of them are probably strongly related directly to economics. So I would say The Invention of Nature by Andrea Wolff. It's about Alexander von Humboldt, who was like a true holistic scientist, maybe the most unknown and underappreciated scientist ever. So the number of rivers, animals, so species, plants, rivers, counties named after him is mind-boggling, because he explored things everywhere and discovered all kind of different things. But at the same time, he in a way was amazing, should I say, sociologist or political scientist. So he was very concerned about slavery in the US. He was very concerned about the boiling tensions between the Prussians and the French. And so a very holistic mind. Also very close to discovering evolution. So he saw I think it was in Russia, that on the one side of the river things were in one way and on the other side of the other. So he discovered the problem. He didn't make that final step of pinning it down that was evolution. He left that to Darwin, but an amazing mind. And then a novel I would mention is, I like to read novels, and one is Slaughterhouse-Five by Kurt Vonnegut. That's maybe closely related to my research, so it's a great book to see how terrible war is. So in that book, he tries to come to terms with the terrible experience he had of he was a war captive in Germany, in Dresden, which was one of the worst massacres and bombings in the history of humanity. And he came out of the bunker, and all of Dresden was flattened. And the book is funny. It's a comedy, as dark as it is, and one of my favorite parts in it is the person who watches war movies in reverse. There's a character who does that, and then so the guns suck bullets out of people, and planes fly and build houses very quickly. So I thought that was a funny way of dealing with such a terrible thing, but without trivializing it.
No, that's great. No, I'll make note of those as well. Now, what's the best way for people to follow your work?
So I'm not the most social media savvy or active person, but on LinkedIn, we're expanding a lot more our presence. So my research is all on my personal websites, but on LinkedIn, we have like a umbrella research group now. It's called Econ AI. So for artificial intelligence, so Econ AI. And there we're trying to ramp up a bit reports about all the work we're doing, also with the SCDO, the German Foreign Office, and a lot of it is about the conflict work, but there's also other stuff that's featured there. So follow Econ AI on LinkedIn to see more about this exploding agenda.
No, that's great. No, so with that, I mean, thanks a lot, Chris. That was an awesome conversation, and good luck with your work. And I hope to keep up to date with it.
Thank you so much.
Great. Thanks a lot, Chris.
Thanks.
Thanks for listening to the episode. Please subscribe to the podcast show on Apple, Spotify, or wherever you listen to podcasts. Leave a 5-star rating, a nice comment, and let other people know about the show. We'd be super grateful. Finally, sign up for our free newsletter at macrohive.com/free. That's macrohive.com/free. We'll be back soon, so tune in then.